Hi everyone, welcome to chapter 5, which is about exponential and logarithmic functions. Since exponents and logs are inverses of each other, we are going to start by reviewing just general ideas about inverses. Hopefully you printed out the handout to follow along. And this first part, normally I would just have you try it in class, but obviously since we're not in class, we're going to talk about it here. Okay. So things that are inverses of each other mean that the x and the y values switch. So for instance, in this first column here, it says f of -2 equals 4. That means that if g is the inverse, g of 4 would equal -2. G of 4 will equal -2. Let me put that over here. Okay. And I'm just going to keep using that information to start filling stuff in. So I'm going to go over here and it says f of 1 equals 0. That means g of 0 equals 1. And it says g of 1 equals 2. That means f of 2 equals 1. And we have g of 2 equals 0. That means f of 0 equals 2. And we have f of 3 equals -2. That means g of -2 equals 3. Let's see if we can fill in that last part here. So we've got g of 3 equals 4. Therefore, f of 4 equals 3. So that's how inverses work. This is actually something you're going to need to be able to repeat, not just this year, but next year as well. Okay, so now we're going to turn this into a more graphical approach as well as actually finding the inverses algebraically. So first of all, I have this function 4x plus 2. It is a line with a y-intercept of 2 and a slope of 4. So there's my line. And I have a couple of ways I could graph the inverse. One of the things I could do is I could actually switch the coordinates of the points. So let me show you that. So I've got this point as 0, 2, and then I found this one over here if I graphed it well. I did not. Let's fix that. So 0, 2 is a point, and then I'm going to go down 4 to 4 and over 1. There we go. I accidentally went over 2 the first time. And that point right there is -1, -2. So when I go to graph the inverse, I just switch the points. So I've got the points 2, 0, and I've got the point -2, -1. So that point right there. And so I connect the two. The domain of the original function is all reals because it's a line, and the same thing with the range. And the new function is a line, so therefore its domain is also -infinity to infinity, and so is its range. But something important to understand is that actually the domain of the original function should match the range of the inverse. And then the same thing for the range. So the range of the original should match the domain of the inverse. It just happens to be that they're both all reals here. Okay, when you go to find the equation of the inverse, you could, now that you've graphed it, just write the equation of the line using the graph itself or the 2 points that are there. But the other thing that you can do is you switch out your x and your y. So remember that f of x means the same as y. So I'm going to make that the x. Oops. And then write this as 4y plus 2. So then this becomes x minus 2 equals 4y, and y equals 1/4 x minus 1/2, which this is now your inverse. So we write it as what looks like a -1 power, but it actually stands for inverse. Okay. Second problem. So our original function is 2 times the cubed root of x. So when I graph 2 times the cubed root of x, that's going to look something like this. Now, actually, you might like it better. That is not an asymptote, by the way. It kind of looks like it here. But you might like it better, actually, if you find the inverse function first, because you'll know how to graph that, and then maybe that'll help you figure out how to graph the inverse. So let's go ahead and do that first. So I'm going to write this as x equals 2 times the cube root of y, which then gives me x over 2 equals the cube root of y, which gives me x over 2 cubed equals y, which again is the inverse. And you can leave it like that, or you could write it as x cubed over 8 equals the inverse. And then that, is a cubed function that has been, the y's have been squished down, right? So normally we'd be at 0, 0, 1, 1. And now we're going to be at 1, 1/8. So it's going to be like this, squished down, or maybe we're even better off leaving it. Maybe I like this better because that's going to change the x's. That'll make it easier for me to graph. So maybe I don't like it with the 1/8. Maybe I like it where I've got 1/2 x, and then I can stretch out my points. So I will have the point 2, 1 and -2, -1. And then I graph it like this. Okay. So this point here is 2, 1, -2, -1, which means my transformed points or my inverse points are actually -1, -2, and +1, +2. Okay. The domain of the original doesn't have any issues, so that's -infinity to infinity, which means the range of the new one is the same thing. And then the range of the original is -infinity to infinity, which means the domain is the same. If you're not sure how I graph that, I just used this x over 2 cubed and used my defining points of x cubed and multiplied all the x's by 2. So I did the transformation process we learned earlier in the year. Okay, so now we have a problem that actually does have domain restrictions that we're going to use for this. So I'm going to start by graphing the square root of x shifted up 1. So the square root of x shifted up 1 will have the point 0, 1, 1, 2, and 4, 3. And I missed that altogether, sorry. 0, 1, 1, 2, 4, 3. And then my inverse will then be 1, 0, 2, 1, 3, 4. Okay. My original function has a domain restriction of 0 to infinity, because I can't have negatives in the radical, which means that the range of the new function will be 0 to infinity. Don't know why I changed colors on that. That's okay. I should have left it. And the range of the original, we shifted it up 1. So the range is 1, infinity, which means the domain of the inverse is 1, infinity. This is an example of a problem where I like to do the domain range first for both of them, because then I won't graph my function incorrectly, or I won't think of it incorrectly, because after we solve it, you're going to see that a lot of people will make a mistake on the domain, because here we are. When I square this out, I get x minus 1 squared equals y. So my inverse is x minus one quantity squared. But if I did just find the inverse, I might not realize that I have this domain restriction because of it being created from the square root function. The only way a squared function has an inverse is if it had a restricted domain when you started. All right, next one. So now this problem is one that we spent a lot of time graphing earlier. So I'm going to go ahead and start with the domain and range of this function. So the domain of this function, I'm going to make it easy on myself. Well, no, I'm not. I'm going to do it with interval notation. So this thing is going to go from negative infinity to negative 4, and then negative 4 to infinity. I can't have negative 4 in the denominator, which means my range will be from negative infinity to negative 4 and negative 4 to infinity. So my inverse gets the same range. And then my range of my original function now might be, maybe you'll remember if you graph it, if this is a struggle as I say this, but this has a horizontal asymptote at 2. And because of the type of function, it is not going to cross the horizontal asymptote. So my range excludes 2, which means my domain will exclude 2 as well. Okay, so you're hoping after you actually find the transformed function that you get those correct domain and range restrictions. Okay, I'm going to go ahead and graph this. So I have vertical asymptote at negative 4, horizontal asymptote at 2. I have an x-intercept at 3/2, and I have a y-intercept at negative 3/4. So this graph takes on this shape here. And if you don't remember how to do these, you're going to want to go back and review. Okay, so now I need to find the inverse function. So I'm going to do the algebra that goes with this. This is usually where the mistakes occur in the algebra step. So each x gets changed to a y, and each y, the only y that I have, gets changed to an x. So I have to solve this for y, which there's some, definitely some issues that can occur with the algebra here. So I'm going to start by cross multiplying. So think of it like that. So here's my cross multiplication, and I need all of the y's on one side. So what I'm going to do is I'm going to distribute the x here. And then I'm going to move the y's to the left side and all the other stuff to the right side. So I have xy minus 2y equals negative 4x minus 4. Now I'm going to factor out a y. And by factoring out a y, I have one y now in the problem. And so now I can divide by x minus 2 to get y by itself. So my final answer here is negative 4x minus 4 over x minus 2. This is the inverse. I'm going to rewrite it up top, and then we can make sure that everything matches on our domain and range. So it is negative 4x minus 4 over x minus 2. And so you can see that the domain is going to be restricted because x cannot equal 2 from the denominator. And then I get a horizontal asymptote of negative 4 over 1, which is restricting my range. All right, I hope that makes sense. Oops. So then there is also a QR codes activity that you can do to help you review this stuff as well. Make sure you write down any questions you have, as well as put them in the question and answer document.